Okay, this video we're going to go over the backside of what we started with, converting between degrees and radians. And on the last video, we basically converted between like a full revolution, a half a revolution, a quarter of a revolution, and so on and so forth. And it turns out that those are the four intercepts if I draw the unit circle in the coordinate plane. Now you know, if I go from here to here, well this makes a 90-degree angle. That's 90 degrees. And we already established 90 degrees. That in terms of radians is pi over 2, and I'll put r. Then if I go from here to here, well, I've gone a half a circle or a half a revolution, which is 180 degrees. And that in radians we established was pi. Now we could say pi radians, or we could also say 3.14 radians. Just know that whenever you have something in radians, you could also change it to a decimal by just putting 3.14 in for pi. Okay, if I go another 90 degrees, we'll add 90 to 180. That gives me 270 degrees. And that we established is 3 pi over 2 radians. And then if I go another 90 degrees, well, I've gone full circle. I've gone one revolution. So it's 360 degrees, which in the unit circle, the circumference is 2 pi. So we'll say 2 pi radians. Okay, so that's what we should know. It's very easy to go from intercept to intercept. You just keep adding 90 degrees, which is the same as pi over 2 radians. Okay, let's look at some angle measures that aren't on the x or the y axis. Okay, they're in either quadrants 1, 2, 3, or 4. And we're going to convert, first part, we're going to convert from degrees to radians. Okay, if I want to convert from degrees to radians, I want to know what 1 degree is equal to in terms of radians. So I established this fact right here, that 360 degrees is 2 pi radians. So if I want to get what 1 degree is, I'm going to take this 360 degrees and divide it by 360. So if I do that, I'm going to squeeze this in here. Right, that cancels. I get 1 degree. And I take 2 pi divided by 360. Let's see here, 2 over 360, that is a fraction we just reduced to 1 over 180. So 1 degree is equal to pi over 180 r, or pi over 180 radians. So this is the conversion factor that we're going to use to take any degree measure, and we can find the distance it is in the unit circle for the arc that it intercepts. Okay, 90 degrees. Now I established 90 degrees is this, pi over 2. I'm going to prove it. Now 90 degrees, if I want to convert this, let's say you forget that it's pi over 2. This is what you could do. If 1 degree is the same as pi over 180 radians, well, to get 90 degrees, I multiply pi over 180 by 90. Okay, when we do that, it's like saying 90 over 1. So you get 90 pi over 180. And 90 out of 180 is a half, so you still get the same thing, pi over 2 radians. And that's all we're going to do. For 2, 3, and 4, I'm just going to take all those angle measures and multiply them all by pi over 180. Okay, I got a little sloppy on that one. Let me erase this. Okay, so to do number 2, I just take 135 and I multiply it by pi over 180. So you would get 135 pi over 180. And then reduce that. Make sure the fraction's in lowest terms. I believe 45 goes into 135 3 times. So that's 3 pi. 45 goes into 180 4 times. So this reduces to 3 pi over 4. Okay, negative 60 degrees. Again, I'm going to do the same thing. I'm going to multiply this by pi over 180. And then let's see here, you would get 60 pi over 180, or negative 60 pi over 180. This would reduce to negative pi over 3. And I'll put r, forgot to put r for these. And then for 225, again, same thing. If I want to go from degrees to radians, I always multiply it by pi over 180. Good way to think about it is usually you always want pi in the radians, so the pi has to be up top. So when we do that, you get 225 pi over 180. Again, 45 would be the common factor. This would reduce to 5 pi over 4. And that's radians. Okay, now let's do the opposite. Let's go from radians and let's switch it to degrees. This is probably what you're going to do a little bit more in the beginning because you're so used to dealing with everything in degrees. Kind of radians is a little bit of a foreign concept, so it might be easier for you if you have something in radians, you want to put it in degrees so you know which angle that quadrant lies in, or which quadrant the angle lies in, excuse me. All right, here we go. Now, if I want to convert from radians to degrees, I want to find out what 1 radian equals. So now, instead of dividing by 360, I'm going to divide by 2 pi. Remember, it says 2 pi radians. So if I divide this, I get 1 r, or 1 radian. And I divide this by 2 pi. And now this is just going to reverse. It's going to be 180 over pi. So if I'm given anything in radians, if I want to put it in degrees, I just multiply it by this, 180 over pi. Now I know pi, I already did that. Pi I established, pi is the same as this, 180 degrees. Let's use the conversion factor to prove that it is equal to 180 degrees. Okay, so the pi, I'm just taking pi and I'm multiplying it by this whole thing here, 180 over pi. And you can see the pi's cross cancel and you're just left with 180 degrees. So it works out. And I just do the same thing for the last 3, 6, 7, and 8. I take the pi over 6, I multiply this by 180 over pi. So you can see how the pi's cancel. So that's kind of a hint for you. You know, somewhere you have to have 180 in pi. Well, if you want to put it in degrees, you basically want to get rid of the pi. See, these pi's cancel. And then 180 divided by 6 gives me 30. So that's 30 degrees, which would be in the first quadrant. For number 7, do the same thing. I multiply by 180 over pi. Pi's cancel. Let's see here. 3 would go into 180, was at 60 times. And then 60 times this 4 will give me 240 degrees. Okay, number 8. And I always put this in there. Number 8, you're like, where's the pi? There's got to be pi in it because it's radians. Well, remember, pi is the same as 3.14. So I could have taken number 5 and say, all right, find the equivalent of 3.14 radians. Just know radians is always a decimal, but a lot of times you have pi. Well, here, I don't have pi in it, but I'm still going to do the same thing. I'm going to take 2, and I'm going to multiply it by pi over 180. Now, this you're just going to get an ugly decimal. So this is where you need your calculator. You're going to do, oh, I'm sorry, I screwed it up, right? It should be the other way around, right? It should be 180 over pi. So when you multiply this, you wind up getting 360 degrees, and you divide it by pi. So I'm going to put that on my calculator right now. 360, I'm going to divide it by pi. And we wind up getting this to be 114.6 degrees. And that would be, now if I said to you, hey, 2 radians, which quadrant is that in? You're probably not going to know right away. But if I convert it to degrees, you're going to know right away, all right, 114.6, that's in the second quadrant. So that's why this really helps out. Like I said, radians is kind of a foreign concept, at least right now. So if you put it in degrees, you know exactly where that angle lies in the coordinate plane. So to kind of sum it up, now this, I'm going to kind of go back to this. All radian measures I can put in decimals. Now I'm just going to put this, I'm going to sum this up. I know this is pi over 2 radians. Here it's pi. Here's 3 pi over 2. And if you go full revolution, it's 2 pi. All I'm going to do right here, I'm going to find the decimal equivalent. So if I take pi, or 3.14, and I divide it by 2, I get 1.57. So look, this makes sense. And I know pi, well that's easy, that's 3.14. This makes sense. 2 radians was 114.6 degrees, which we said is in the second quadrant. Well, this 2 is in between 1.57 and 3.14. Okay, then if I did 3 pi over 2, that equals about 4.71 radians. And then 2 pi, if you double pi, it's just 6.28 radians. All right, so I just did that at the end. So just know that radians, most of the times, I'll say about 90% of the times, you're going to see it written in terms of pi, but not all the time. And that's what we did for number 8, and I related it to this right here when I take the radians and put them in terms of a decimal.